Hello, I'm Neeraj. So today, in this part of the tutorial, I will try to explain that how we can use the RAG and create a knowledge graph for a given text. So to get the knowledge graph, what kind of things are required? It requires like what is the subject, what is the relation, and what is the predicate part. Or you can say that uh, entity 1 relation and then entity 2. So you can use it at different names. So generally we prepare triplets. So once we prepare all the triplets for a given text, we can easily convert the entire text into the knowledge graph. And how we can do it by using RAG. So this is a very interesting applications. But before going into the detail, I will suggest you to go through the first part of the tutorial. Then you will be able to understand a lot of basic things like what is RAG, what is retrieval augmented generations, how it is working, and for the entire knowledge graph generations, I have used Olama window version. We downloaded the Olama window version, and after that, I have used the Llama 3 model with 8 billion parameters. It is working on just a 16 GB RAM system, and for language embeddings, I have used the Max MXBI embedding large. Already explained in the previous tutorials that I am using this because it performs better than all the existing SOTA till March 2024. So this is the reason. Now let us start with the code. So as in the previous code I discussed about the basic RAG architecture, I took a very simple information about quantum mechanics that I copied from Wikipedia. I took around 7 sentences from the starting and stored it in a two-dimensional array. Instead of that, you can take documents, multiple documents, PDF files, text files, you can do anything. After that, we took a ChromeDB. ChromeDB is a vector database. We call the client of vector database ChromeDB. Now after that we apply the embeddings. For embedding, why we are using embedding, that I already explained in the previous tutorials, that all the large language models store the informations in the form of vector. They convert each of those words in a form of vectors like that, for this word and another vector for this word, like that. So we also require to convert our text or our prompts into the similar kind of embeddings. So we embedded it by using MaxBI embed large. Now, so here I have used two prompts. The first prompt is just a similar to like a basic RAG questions, and the second prompt generally asks system to list all entities and generate the knowledge graph triplets by using all entities. Means it will use all these entities and generate the knowledge graph triplets and knowledge graph triplets for this text. So this is our prompt 2. I have explained that how we can use multiple prompts. For simplicity, I have used it sequentially. So first we will handle the first prompt we already handle the document. We can embed the documents, and after that we will embed the first prompt. We will identify the, in result 1 we will apply the query from this collection where we stored all the embedded informations related to this text, and then we will query the relevant information from that is related to our prompt 1. So that I already discussed. So this is required for general question answering. Now the second part is list all entities and generate the knowledge graph triplets by using all entities. So now all those models are sufficiently well in understanding those things, then it will consider that we are asking some task over that. So those prompts are actually related to two tasks. So first of all, we will embed the response to related prompt. That prompt 2 we will embed and store it in response 2. And after that, we will try to identify the query. But actually, query will have, because you have embedded information about this text and then embedded information about this prompt. Both are totally different things, because your text contains some information about quantum physics, quantum mechanics, but prompt 2 says some command that should be on the top of this text. So here the system will take it differently. So once you embed your prompt 2, it will generate the embedding, but when you query it from this text, the system will identify very few matches. This means you are saying or applying some command over those texts, so it will be considered like that. So based on that, it will combine both information and give you as a result in a data 2. So when you provide those as a query to Llama 3, let us see what will happen. It will generate two things. First, it will answer your first questions like it answers previously. After that, it identified some entities like quantum mechanics, theory, physics, nature, atom, scale. So the system identified those entities, and using those entities, system has generated the knowledge graph triplets. Now you will say that how we can construct the knowledge graph with these triplets. So it is very easy. You can use any of the package to construct the knowledge graph from these triplets. For example, suppose here you have, I have just written this code by using network X. So here we have to just replace this like now this way I have converted it. So when I run this, it will create a beautiful knowledge graph for your entire information. So here you can see that yeah, this is a little, yeah, you can expand it and make it better. And you can use some other packages as like so quantum mechanics is a fundamental theory in physics. It is related to physics. It describes the behavior of nature and works below the scale of atom, and is related to some atoms is related to some scale, means we can, so that way it actually prepares the knowledge graph for a given text. So here I just use the network X, but you can use some better libraries, or you can use some Neo4j or some other packages, Apache packages also to construct this. So I think this is one of the simplest way to explain that how we can construct the knowledge graph. And other than knowledge graph and entities, you can do a lot of NLP tasks. Like you can extract noun phrases also, you can extract verb phrases also, you can do some chunkings also. Means because in the prompt I found that if you write the proper prompt, the system will execute and give the correct answers.